Hi, welcome back to topic number 15, saving money. So in this video, let's take a look at the second objective, something called annuity. So what's so-called annuity is a sequence of regular payments made into an account or taking out of an account over time. So, so this is basically what we discussed last time with the investment. Okay, your 401k is actually a type of annuity where you constantly, every paycheck, you actually put some money into that account. All right. So annuity formula for finding the future value. Okay. The future value is called FV. Future value is equal to the payments. Okay, that is deposited on a regular basis. So this payment is the amount of payment we actually deposit on a regular basis. So right now we are actually what we actually doing is paying ourselves, make payment to ourselves into our investment account. All right. R is your APR. N is the number of the regular payment made in each year. Okay. So if I am making monthly payment into this account, then N got to be 12. If I make quarterly payment, there are 4 quarters in a year, which is every 3 months. So if you are making quarterly payments, that means N will be 4. All right. T is also got to be in years. So let's check it out. This problem. Let's say Wendy starts an IRA at the age of 26 to save for retirement. She deposits $400 each month, okay, into this IRA account. The IRA has an average annual interest rate of 6%. Okay. How much money will she have saved when she retires at age 65? So in order to find so if she's gonna retire at age 65, then the time of the investment got to be 65 minus 26. So that tells me that she will be saving for 39 years. Okay, the younger you are, the sooner you need to start. Okay, you can actually build up quite a bit of money over time. All right. So how much money will she have saved? So this problem doesn't ask you, okay, it's not really asking you how much money she will, well, this money does ask you what the future money she will have. So let's try this formula real quick. Future value is equal to her monthly payment of $400 times, okay, the top has a big old bracket, parenthesis, 1 plus R is 0.06 divided by, she's making monthly each month. So that means my N gotta be 12 because she's making 12 payments. Whole thing raising to the N times T, which is 39 years. Then minus 1. Whole thing divided by R times N. 0.06 divided by 12. All right, so this is a little bit tricky to key it in. So let's make sure we understand this. This $400 payment, this number up front, multiplication means 400 over 1. So that means this 400 technically is going to be on the top. So we can key all that in together. What we want to do before we key it in is figure out this exponent. Makes it a little bit easier. All right, check it out. 12 times 39 years. So she will be making 468 payments. Now I'm going to take the 400 times the bracket is going to be a parenthesis. Open another parenthesis for the 1 plus 0.06 divided by 12. Close parenthesis. Then exponent. All right. 468 minus 1 close parenthesis. All right, so let's look at what I just keyed in. According to the order operation, it will do what's inside the parenthesis, the most inner parenthesis first. So the 0.06 will divide by 12 first, then plus 1. And then on the outside the inner parenthesis, there's an exponent. So it will actually raise into the 468, which is what I want. I need to figure out this front part first. Whatever that answer is, I want a minus 1. Okay. Then after minus 1, that's why this extra parenthesis outside is needed. Then times by 400. All right. So now we're going to press enter. Then we're going to divide it by, let's putting this one term down here in the parenthesis. 0.06 divided by 12. So she will end up with $745,670.73. Okay. So this problem we're keying a little bit different. I want to key in the top first and then divide it by the bottom. The bottom is simple to key in. So what happened if I would do the same thing? Just do $100 a month. Just $100 a month. And that's at 6% rate of return. Give me about $186,000. Okay. So this is actually, think about this though. Think about this. If I put in $100 for 12 months a year for 39 years, I only put in $46,800. That's actually my money. And that $46,000 over time is actually going to grow into $186,000. Okay, so you actually earn quite a bit of interest. All right, so let's try this one. This apartment is a little bit different. Wendy starts an IRA at age of 34 to save for retirement. She is going to deposit $450 each month. Upon retirement at age of 65, her retirement saving turned out to be $959,293.31. Determine the amount of money Wendy deposit over the length of investment and how much she made in interest. So this is just like what I just did, basically. So the time she invested, 65 minus 34. That will be 31 years. She invests for 31 years. So she is putting $450 a month times 12 months in a year for the next 31 years. So if you put this in a calculator, it will tell you that she has deposited $167,400. Okay, that's the first part of the question. What she deposit over time? All right. Now, how much interest she made? So she only put in $167,000, but the account actually grow into 959,293.31. So you take that, what she end up minus what she put in, and it will tell you this account has earned her $791,893 and 31 cents. Okay, that's how much you actually earned her. So if I go back and take a look at this same exact problem, but if I will raise it to 12% earlier, that problem we did with the 6%, 12% in return divided by 0.12 divided by 12. Okay, so there we go. That's over $1 million. So the rate of return matters. Okay, the rate of return matters. Well, Mr. Chen, it's hard to get that 18% you're talking about. Well, think about this. It's if in order most of the credit cards are about 18% or higher. So can you imagine if you're not paying people 18% in in APR, in a way you are kind of receiving 18%. Okay, it's kind of weird concept because if you're not paying other people, because other when you borrow money from the credit card, that means they're investing into you. They expect you to make to give them payments. So when you don't have to pay other people 18%, mysteriously you are actually receiving in 18% interest. Okay. All right. Let's try this. Okay. This is a reverse of this formula. This is actually finding the regular payment needed to reach a certain value, to reach a certain future value that you want. Okay. So this is the same thing except I'm actually now want to find the payment itself. So if you have a goal in mind, okay, I say, okay, I want to be a millionaire, at this age. How much money do I need to put into my retirement account at that interest rate? Okay. So suppose we should retire at age 65 and you want to end up with $80,000 in saving. Determine your monthly payment into this IRA if the IRA account is earning 7.5%. So my monthly the payment I need to pay myself is equal to my future value, 80,000. So this is just like earlier. This 80,000 means over 1, so you'll be actually be viewed as on the numerator. Times R is 0.075 over, I'm doing the monthly payment, so that'd be over 12. Whole thing divided by bracket 1 parenthesis 1 plus 0.075 whole thing divided by 12 and raising to the 12 times, what's my time? 65 minus 65 years old minus 20 when I started. That's actually 45 years. So that will be times by 45 and then minus 1 close bracket. So this one is a little bit tricky to key in, okay? But I think we can do all at one time. So if I will say this 80,000, this number up front, the future value is on the numerator. So then what I'm going to do, I'm going to key this all at once. I'm going to start with a parenthesis because I want the whole entire numerator to calculate at one time. 80,000 times parenthesis 0.075 divided by 12. Close parenthesis for the division, close, close parenthesis for the entire numerator. Now I'm going to divide it by, okay, all right. The bracket is going to be a parenthesis. Open another parenthesis for the 1 plus 0.075 divided by 12 and close parenthesis, exponents. So 12 times 45, I'm going to open another calculator. I suppose to figure that out first. 540. So raised into the 540 power and then minus 1. Close the bracket. Okay. It's weird. It does the most inner parenthesis first, then do the exponent next before you will subtract 1. Voila. So what I need to pay is $17.91. That's all the payment I need to make in order to end up with $80,000 after 45 years. All right. Suppose Wendy like to save enough money to pay cash for her next car. All right. The goal is to save an extra $21,000 over the next 6 years. What amount must be deposited quarterly? Remember now, this is quarterly, okay? Into an account that earns 5.6% interest. So it's almost like this problem is almost like saying a bank is lending you at 5.6% over the next 6 years, okay? And and what they loaned you is $21,000. So we kind of reverse that. So let's say I'm gonna pay myself first. I'm gonna pay myself first, save all the money, and then go buy this car with cash. Well, Mr. Chen, what happened if I was short? Well, it's hard. It's hard for the car dealership to walk away with $21,000 in cash. You might be able to find a better car. So let's give this a try, okay? So what must be deposited quarterly? All right. So $21,000 times. So it's the same thing as what we just did. All right. R over. Be careful right here. Over and I'm making quarterly payment into this account. So that n is 4. Holding raising to the bracket 1 plus 0.056 divided by 4. Holding raising to the 4 times 6, right? 6 years. So that's 24 payments basically. 4 times 6, that's you're paying yourself 24 times. Minus 1. All right. So what should the quarterly payment be? Oh, sorry, I need to start it with a parenthesis. Times open parenthesis point. I don't have to have an open parenthesis because it will actually multiply, then you will divide. It made no difference. But it's all right since I wrote the parenthesis earlier. I'm gonna keep it 0.056 divided by 4. Close parenthesis for the division. Close parenthesis for the entire numerator. Divided by. Open the bracket. Open the parenthesis for the 1 plus 0.056 divided by 4. Close parenthesis for the 1 plus raising to the 24 power. Then minus 1. Close the bracket. $742.27. Quarterly. All right. So every quarter I will pay that much money. So if you divide that by uh, every quarter has 3 months, right? 4 quarters, 3 months each. So that means every month $247. So that's about you know, that's about a lot of people's car payment right here. Remember, car depreciates over time. Okay. So if you finance a car, by the time 6 years later, that car is no longer worth $21,000. Okay, it's definitely not a brand new car 6 years later, because by saving our money, go purchase a vehicle. That vehicle is actually brand new. Okay, $21,000. Even though the moment you drive off the lot, it depreciates, but still, you pay cash for it. Okay, no payment attached to it. Insurance is also cheaper too. All right, let's take a look at this last one. Wendy wished to retire at age 67 with $1.1 million in her retirement account. That's the goal. When she turned 22, she decided to begin deposit money into an account with an APR of 7%. Okay, these APRs are very low. What is the monthly deposit that she must make in order to reach her goal? Okay. Let's see. What is a month? I think I'm missing a question here. I was keep on looking back. I might miss a question, but I will go find it. All right. So the payment is equal to her future value, $1,100,000 times 0.07 over let's say monthly deposit, so that's 12. Whole thing divided by bracket, parenthesis, 1 plus 0.07 over 12, raising to the 12 times, how many years is this? 67 minus 22, that's 45 years later, and minus 1. Okay, so let's figure it out. 12 times 45, my exponent's going to be 540. So 1,100,000 times, oh, gotta start with a parenthesis first. Open parenthesis, 0.07 divided by 12. Close parenthesis for division. Close the parenthesis for entire numerator. Divided by, open the brackets. Open the parenthesis, 1 plus 0.07 divided by 12. Close parenthesis. Exponent, 540. Then minus 1. Okay, so she will need to make $290.04 payments. Okay. All right, I think there's one more question. I'm gonna go find it real quick. Sorry about that. I forgot to. Uh, oh yeah. So I'm gonna wrap it up this topic. Sorry, this is gonna be loud. With purchasing a dream home. All right. So here we go. A couple is purchasing a dream home. They wish to save money for 10 years and purchase this dream home that has a value of $150,000 with cash. If they deposit money into an account paying 7% interest, how much do they need to deposit each month in order to make the purchase? So remember, once we find that out, once we find this answer, okay, um, got the cash, money is ours, okay? How much do they need to deposit every month? All right, so here we go. $150,000 times 0.07 divided by monthly, right? Whole thing over 1 plus 0.07 divided by 12. They only want to save it for 10 years. So that will be 12 times 10. 120 payments minus 1. open parenthesis, times open parenthesis, 0.07 divided by 12, close parenthesis for the whole numerator, divided by bracket, parenthesis, 1 plus 0.07 divided by 12, whole thing raising to 120 and minus 1. Close the bracket. There we go. $866. So, um, so if we make $866.63 payment for the next 10 years, um, we basically, we basically have a house of our own. It's recommended that, see, normally the mortgage is about 30 years. Okay. Mortgage is 30 years. So if people, all right, let's try it this way. If a mortgage is 30 years, okay, so let's just say our mortgage ended up to be $866.27 or excuse me, 63 cents. So times by 12 months a year times by 10 years. Okay. That means we have paying. So imagine that if our mortgage payment is $866, we go ahead and finance it, borrow it. All right. So 10 years I actually paying $103,000. So imagine a 30-year mortgage with $866. You'll be paying twice of a house. Okay. So what happened is the longer we mortgage our house, the traditional years of mortgage is 30 years. You're actually gonna end up paying two houses. As compared to this problem is showing you that if we can save money ahead of time for down payments or even the whole thing, okay, to purchase a house, okay, then we will be paying a lot less. If we can pay in less money to purchase a house, then we can turn around, sell that house, higher than what we pay for. And we can actually make some money, okay, by selling our houses. Okay. So rule of thumb, never flip a house with a borrowed money. Okay. All those money that all these shows that you see where people flip houses, those are cash. They did not borrow the money to flip the house. Otherwise, what happened? The house doesn't sell. Okay. So I want to finishing up this problem by coming back to the $1 million ones. Okay. The $1 million problem, I remember earlier, her monthly payment was $290.04. So imagine $209 a month, okay, times 12 month in the year times, I think the problem says what, 45 years investment. Think about this. In For the 45 years, she actually put in $156,000, but that $156,000 actually earned her $943,378 in interest. Okay, so this is how the math is done. Okay, so think about it. All right, thank you for watching. That will conclude our topic on personal finance.